So we'll complete it. So today ஒரு 4-5 derivations இருக்கு. So for that I'm just doing that live. Okay, இந்த derivations எல்லாம் நம்ம முடிச்சிட்டோம்னா after that prism இருக்கு. Prism then you don't have that race, right? That is eye defects கிடையாது. You don't have that eye defect, correct?
Yeah.
And we'll try to directly start your microscope and as well as telescope. So chapter on the next class will number complete. And after that we'll do problems in the one class. Then we'll complete. So right, so we'll start. So right, Mas. So here we are going to start your refraction at your spherical surfaces. So as we know that convex irukku, concave irukku, there are two types of surfaces are there. But with respect to surface, number refraction pattha discuss pannittom. Let's see. It is not a mirror; it's just a refraction. Remember, make a heading: refraction, refraction, refraction at a convex, refraction at a convex spherical surface. Refraction at a convex spherical surface. Right. So here I'm just taking the convex first of all. So in a cases then we'll discuss convex or concave answer. So here what we are going to discuss. So either on the first of all we'll discuss about your convex. We'll discuss about the convex. The convex spherical surfaces on the first of all we'll discuss about the rarer, okay, to denser medium. A light ray passes. Rarer to denser. Remember, rarer to denser on the light ray pass and we are creating a real image. We are creating a real image under convex. Now discuss one. Second part, same rarer to denser. We'll discuss about the virtual image. We'll discuss about the virtual image. And remember whether it is virtual or real. So when you are discussing about the rarer to denser, we'll create a relation with respect to the refractive index, which is your rarer. I'll take it as mu1, and denser I'll take it as mu2. Okay, and after that, so we are going to change that object's position. So third one, we'll see the object and the image from denser towards the rarer. Object is denser, so the image will be forming at the rarer. Again, in denser to rarer, we are going to discuss about your real image. Okay, so next one, we are going to discuss about the same denser to rarer. We'll discuss about the virtual image. Okay, so here also we are going to discuss a relation. So in this relation, so remember here this is your rarer to denser. Now it is your denser to rarer. There are two formulas out there. These two formulas are so much important. Same thing for your convex also. Sorry, concave also. Concave adhe madri rarer to denser will see a real image and as well as virtual image. Same thing, denser to rarer, it is your real image and as well as virtual image. But remember, when we're discussing about the spherical surfaces, convex are the real and virtual and certain number form control. It is purely opposite to your mirror. But concave will only specify your virtual images. Either on the real images form agadu. So here, remember, virtual images mattunda irukundi. Okay, so concave, when we are discussing about the rarer towards the denser or denser towards the rarer, we'll only discuss about the virtual image. Remember it. So here there is one formula and here one formula. So these two relations are same. Whether it is concave or convex or real or virtual, doesn't matter. Only it matters about the medium. When the light ray passes from rarer to denser, or relation or the denser to rarer or relation. These two relations compared to these two relations. When you are using these two relations, from these two only, we are going to discuss about the lens maker's formula and as well as thin lens formula. Okay, so render relations. So we are going to discuss one by one. Make a heading: refraction at your convex spherical surface. First of all, we'll discuss about the convex spherical surface. Convex spherical surface. So when we are discussing about the convex spherical surface, so here, first of all, I'll take first case. As a first case, we'll discuss about the real image. Real image. So let's see, other ray diagram number discuss panna. So what I'll do, as usual, there'll be a reference line. So I'm just taking a principal axis. Assuming this is your principal axis. Now I'm just discussing over the convex. Convex, it is your bulged out side. This is your bulged out. This is your convex surface. And idhukku vandu denser medium irukum. This is your denser medium. And air medium is your rarer medium. So here it has its own density. It is your denser medium. And it is your rarer medium. So I'll take this one as air medium. And here it is your glass. And now the number refraction pattha discuss. Now when we're discussing about the refractive index, I'll take this one as mu1. And I'll take this one as mu2. Let's see that relation. So this is your mu1 and mu2. Now what I'll do, I'll take a light ray in your rarer medium. So the medium is nothing but a light ray passing from rarer towards the denser. Now discuss pandradinge. First case, so it is a real image and the light ray passes from a rarer to denser medium. A rarer to denser medium. We'll try to understand the terms, characteristics and so on. So first one, it is your principal axis. This is your principal axis. And where the curve meets the point we call it as a pole. Okay. And for this curve structure, there is a center point. So the center point we call it the center of curvature. And we call it as focus. So as you already know these things. And let's say the distance. The distance is from the pole to the center of curvature. The distance is your radius of curvature r. From the pole to the focus, we call it as your focal length. Yeah. So radius of curvature half is your focal length. Yes. So I'll take it as smaller for focal length. So these things you already know. Now let's see. So I'm just taking an object. I'll change the color. So I'll just take an object. I'm just taking this object from your rarer medium. So let's see, this is your object. This is your object. So what I'll do, I'll pass a light ray from a rarer medium towards a denser medium. So the red color line is your object light ray from the object. So this light ray we call it as your incident. So now the ray diagrams because it is your first one. I'm just explaining. So please take it out. So this is your incident. And now, so you already know there will be a normal line. This normal line will be passing from the center of curvature. This is your reference line. So this is your center of curvature line. We call this line as your normal line. So this is your normal line. Okay. So with respect to the normal line, when the light ray passes from rarer towards the denser, what will happen? It will try to travel towards the center of curvature. That means your normal line, towards the normal line. When it is passing towards the normal line, so the light ray will pass through it and it will try to bend. There is a refraction and the image is forming near to your normal line. So this is your image. So image and if you see that the distance is so object to the pole, the distance is u. Object towards the pole, the distance I'll take it as u. And image to the pole, the distance I'll take it as v. Distance I'll take it as v. So first of all, we'll try to understand the angles. Then we'll see the sign conventions. So I'll take this point because it is crossing out. I'll take the point as n. I'll take this point as n. Now, if you see that the object is creating an angle with respect to your principal axis, same thing. So the center of curvature is also creating an angle, and as well as the image is also creating an angle. So what I'll do, I'll take some angles. So object, it makes an angle alpha. I'll consider this as alpha. Image, I'll take it as beta, and the center of curvature, I'll take it as gamma. And you already know there is an incident ray. The incident ray is between your incident, incident angle is between your incident ray and the normal. So this angle we call this incident angle. And the angle between the refracted ray and your normal we call it as refracted angle R. Okay. Now, so this is your picture. This is your ray diagram. So you'll try to understand the triangles formation. So here to make it comfortable, what I'll do, because it is a curve structure, so instead of taking the curves and all, what I'll do, I'll take a straight line perpendicular to the normal line. When I take a perpendicular to the normal line, so we can eliminate the bent portion. So I'm just taking this perpendicular line. I'll take the point as M point. Remember, this is your M point. I'm just neglecting the bended portion. Now, in this case, in this ray diagram, I'm going to consider two triangles. First one, the triangle NOC. Triangle NOC. I'll write here. So first one, I'll take triangle NOC. I'll write here. Now, so I'll take triangle NOC. So from the triangle NOC, so where if you see the triangle NOC, this is your N point, this is your O point object, I'll take it as O. And image, I'll take it as S. Okay, I. Okay, so from the triangle NOC, NOC, remember NOC. So from the triangle NOC, the exterior angle is I. So the exterior angle is nothing but your summation of your interior angles. From this relation, we can say I is your exterior angle, which is equal to your interior angles, that is alpha and gamma. So I is equal to alpha plus gamma from the triangle NOC. Now same thing from the triangle NIC. From the triangle NIC, just see that. So from the triangle NIC, this is your N point, this is your C point, and I. So this is your NIC. From this triangle, gamma is your exterior angle. So from this relation, gamma is equal to your R plus beta. Gamma is equal to R plus beta. But I need the refractive angle. So refraction R is equal to gamma minus beta. So I'll take this one as first relation. I'll take this one as second relation. Now we got the angles here. So let's see. So from this case, what I'll do, so here there are three different angles, alpha, beta, gamma. Remember, alpha, beta, gamma, all three angles are your small angles. Okay. Now, so in these cases, what I'll do, I'll try to find your alpha, beta, and as well as gamma. And whatever the red line we have drawn, this is your hypotenuse. Between three different angles, there is a common point, that is your NM. NM is perpendicular to your principal axis. Let's see the relation. So from this, so forget about the hypotenuse. We know the distances, that is your O to M, M to I, and M to C. That is your distance. And we know the common point, that is your NM. We are going to neglecting the hypotenuses because we don't know what is the hypotenuse. We are neglecting the hypotenuse. So for that, what I'll do, I'll take tan alpha. For the first angle, tan alpha. Tan alpha is equal to, we know that that is your opposite and as well as your adjacent. Opposite, I'll take it as NM divided by adjacent is nothing but your MO. NM by MO. So I have clearly told you, I'm just neglecting the small bend portion. Instead of that, I'm taking a triangle. That is your perpendicular line. So to make it comfortable, creating a triangle here. So we can neglect it because it is your small angle. So tan alpha is equal to NM by MO, and tan beta is equal to, from this relation, NM is your common point. NM divided by your MI. And tan gamma is equal to your NM divided by your MC. Okay, so from these relations, I told you alpha, beta, gamma are small angles. Alpha, beta, gamma are small angles. Alpha, beta, gamma are small angles. Now, so from these small angles, I can neglect the tan functions. So from this relation, alpha is equal to Nm by Mo, and beta is equal to Nm by Mi, gamma is equal to your Nm by Mc. Now, in this case, so I'm going to see the Snell's law. So you already know about the Snell's law. Snell's law, here the law is related to your density towards the river. When you're discussing about the density towards the river, the relation is from the Snell's law. So the refraction relation 1 with respect to 2 is equal to, that is radius towards the denser, the relation is mu2 by mu1, which is equal to your sine I divided by your sine R. So what I'll do, I'm going to multiply these two. So mu1 into sine I is equal to mu2 into sine R. So I told you the functions and the angles are your small functions. So I'm neglecting the sine. So because angles I and R are so small angles, so we are going to neglect the functions. Tan and sine functions we are going to neglect. So mu1 I is equal to mu2 into R. I'll take this relation as third. So what I'll do, I'm going to substitute I and R in this relation. When you do substitute, what will happen? So the relation is like this. So mu1 into alpha plus gamma is equal to mu2 into your gamma minus beta. So I'm going to substitute alpha and gamma. So in this relation, this is your NM and those relations in your third relation. When I do substitute, so what will happen is, in this case, so mu1 into alpha is, it is Nm by Mo plus gamma is Nm by Mc plus mu2, sorry, is equal to your mu2 into your Nm by your gamma, it is Mc minus Nm by Mn. In this case, Nm is common, so I'm just cancelling out Nm. Okay, so I'll write the relation here, mu1 into 1 by Mo plus 1 by Mc is equal to mu2 into 1 by Mc minus 1 by Mn. So till this, please take it, then we'll continue. So if you have any doubt, please take it. Just try to understand, this is your convex, and we are discussing about the real image. When the image is forming within the mirror, we call it as real image. In front of the mirror, within the refraction, it is a real image. So here, when we are discussing about the extended points, traceable points, that is your virtual image. We'll discuss in next class. So try to take it. If you have any doubt, please let me know.
You're done.
Yeah, okay, good. So let's. So in this case, so I'll rewrite the final relation in the next page. So the final relation is mu1 into 1 by mo plus 1 by mc is equal to your mu2 into 1 by mc minus 1 by mi. So this is your final relation. Now in this final relation, so we are going to discuss about the sign conventions. So can you tell me sign conventions are either the negative, either the positive? Which terms are negative?
So U is negative.
Yeah,
V is positive,
yes,
and F is also positive.
yes. R is
R is also positive.
positive. Yes, I'm going to substitute here. So from this relation, let's see what is MO, what is MI, and what is MC. So from the sign conventions, Cartesian sign conventions, let's see. So what is MO? MO is nothing but your object distance. It is your towards your left side, opposite to your incident ray. I'll take it as minus U. MI is nothing but your object's distance, image distance. Image distance, it is towards your right side, and it is the same direction towards your image, incident ray. So it is plus V. Okay. And இது வந்து center of curvature இருக்கு, and it is towards your incident ray இருக்கிறதுனால இது வந்து radius of curvature positive. I'm going to substitute that relation here. So mu1 into 1 by mo, that is your minus u, plus 1 by plus r is equal to mu2 into 1 by r minus 1 by v. So what I'll do, r terms எல்லாம் ஒரு side நான் எடுத்துக்கிறேன், and மற்ற terms எல்லாம் ஒரு side நான் எடுத்துக்கிறேன். So what I'll do, mu1 by minus u minus of minus into plus ஆகும், plus mu2 by v is equal to mu2 by r minus mu1 by r. So let's see. So நான் என்ன பண்றேன்னா இதுல வந்து I'm taking the minus here. So in this relation mu2 by v, remember mu2 by v minus mu1 by u is equal to, so it is a mu2 minus mu1 divided by r. So remember this relation. So in the relation எங்கே யூஸ் ஆகும்னா when the light ray passes from your rarer towards the denser. Rarer towards the denser, and இங்கே discuss பண்ணது it is a convex spherical surface refraction தான், இது வந்து reflection கிடையாது, refraction, and we have discussed about your real image. So you have to use this relation. Just take it.
So done.
So let's see the second case. So the second case is same convex, but we are going to discuss about your virtual image. The second case. So it is your convex spherical surface. The same image is in your denser, and the object lies in your rarer. Object lies in rarer medium. Okay, and we will discuss about the virtual image. The image form is virtual image. Virtual image. Okay. So let's see that. So here there is a principal axis. This is your principal axis. So for this principal axis, I'll just take a convex spherical surface. So this is a convex spherical surface, and as you know that this is your pole, and this is your denser medium. So it is the center of curvature here. This is center of curvature, and there is a focus. Right. So this is your principal axis. Now what I'll do, I'll take an object. This is your rarer medium. So rarer medium, and I'll take this mu1. Denser medium, I'll take this mu2. So let's see the light ray. So remember here we are going to discuss about the virtual image. When we're discussing about the virtual image, just try to understand here it should be closer to your pole. Remember, it should be closer to your pole. And the virtual image should be formed in front of your mirror. So within the mirror, this is your real. In front of the mirror, that is your virtual. Let's see. So here what I'll do, I'll take a object. So here, this is your object. So from this object, I'm just allowing a light ray. So light ray is fallen. So what will happen? It will try to refract. The refraction eppadi irukuna, so it will be towards a normal line. So let's see. So this is your object. I'll take it as O, and it makes an angle alpha. Other distance from the pole, we know that this is your U. Now let's see. So there is a normal line. Normal line on the center of curvature and the pass agum. Okay, this is your normal line. Okay, so normal line. Okay, now light ray will be bending. So when the light ray bends, so it will be towards the normal line. So let's say this is your towards the normal line. Okay, so here when the light ray bends, so it is not your convergence. This is your divergence. Okay, now I'm going to trace out, tracing backward direction. When I'm tracing backward direction, the image will be forming in front of the mirror. Let's see. So here, so when you trace out a line, so the image is forming at this point. This is your image. Remember, this is your image, and here it makes an angle of beta. It makes an angle of beta, and here it makes an angle of gamma. So alpha is your incident ray, and it makes an angle of incidence with respect to normal line. This is your angle of incidence, and there is a refraction. Refraction will be there. This is your refraction R, and idukku parallel da irukadunala. So the refraction will be happening with respect to your normal line. So idu alpha irukku, beta irukku, gamma irukku. Let's see the distances. O point and the P point, the distance is U, and that is your P point to C point, the distance is your R, and P point to your image, the distance is your V. Okay. Now, so angle of incidence is angle of refraction. I'll take this point as N point. The point of the I'll take as N. And idukku perpendicular, that is principal axis to perpendicular, I'll draw a line. So to close the curve structure, so to make it comfortable. So I'm just closing the curve structure. I'm just taking the perpendicular line. I'll take this one. This is your perpendicular. Okay, let's see the relations. NM is your common point. As usual, number munadi enna discuss pannirukkom, same things here. So what I'll do, I'll take the triangle NOC, and I'll take the triangle NIC. So from this, the outer exterior angle is equal to your summation of interior angles. Let's see from this relation. The outer angle is nothing but your angle of incidence. So I is equal to your alpha plus gamma. Remember, it won't change. Only refraction will change it. In this case, so if you see that the exterior angle is nothing but your R. So NIC. So N, I, and C. So exterior angle is your R. So in this case, R is equal to, remember, R is equal to your beta plus gamma. I'll take this one as first relation. I'll take this one as second relation. Same thing, I'm going to find your alpha function. So here tan alpha is equal. So angles are so small, I'm removing the tan functions. Alpha is equal to, the relation is your opposite side divided by your adjacent. Adjacent is nothing but your MO. And beta is equal to your NM divided by your MI. And gamma is equal to NM divided by MC. So we got alpha, beta, gamma. Now what we are going to find, we are going to see your Snell's law. So Snell's law, the relation is rarer towards the denser. So it is 1 mu 2, which is equal to, it is sine I divided by your sine R. So it is equal to mu 2 divided by mu 1, the ratio. So here, what I'll do, I'll multiply it. Multiply panama sine function is, that is angles in so small, I'll remove the sine functions. So I'll remove the sine functions. It is I divided by R. I'll multiply it. So that is mu 2 into R is equal to mu 1 into I. I'm going to substitute the relations. So it is a mu 2 into R is nothing but your beta plus gamma, which is equal to mu 1 into I. I is nothing but your alpha plus gamma. So alpha, beta, gamma, I will substitute the relations here. So mu 2 into what is beta? Beta is equal to Nm divided by Mi plus, so gamma is Nm divided by your Mc is equal to u1 into Nm divided by your alpha. Alpha is equal to Mo plus this Nm divided by your My. So Nm will get cancelled here. And from the sign conventions, so you already know, towards your left side all are negative, towards your right side all are positive. So here left side answer Mo is your alpha angle, that is your object. I'll take it as minus u, mi is equal to minus v because it is a virtual image, and mc is equal to your refraction plus. Okay, that is your radius of curvature because it is towards your right side. I'm going to substitute the relation. So mu2 into mi is nothing but your 1 by minus v, okay, and mc and so on plus 1 by r is equal to mu1 into mo and so on 1 by minus u plus 1 by r. So r terms ஒரு side, மற்ற terms ஒரு side. So the relation will be, so it is a mu2 by minus v, just see that mu2 by minus v. So here minus இருக்கனால I'll shift it towards left side, so it is mu1 by u, which is equal to, so it is a mu1 by r minus mu2 by r. So I can write this relation like this, or else I know minus common method. When I do subtraction, minus common method, mu2 by v minus mu1 by u is equal to, the relation is mu2 minus mu1 divided by r. Remember it, இது முன்னாடி பார்த்த relation, இந்த relation both are same. So that means when the light ray passes from rarer to denser, okay, real or virtual, it doesn't matter. When it is rarer to denser, in the relation we have to consider. Okay, please take it. This is your second question.
You're done.
This one. Let's see next one. So next one is your third case. Third case, now the object lies in your denser medium. Remember the ray diagrams based on the concept. Okay, you have to understand your ray diagrams. The third case. So third case, object lies in your denser medium. Object lies in denser. Earlier it is your rarer, now it is denser medium. Okay. So and the image is formed real. Image is your real image. Okay. So let's see the picture. So as usual, there is a principal axis. And இதுக்கு principal axis. So here we are going to discuss about the convex spherical surface. So convex. So now I'll try to reverse it. So now the convex I'll just take like this. Okay. So I'm just assuming towards your left side is your denser medium. Assuming this is your denser medium. Okay. So I'll take the relationship. So center of curvature in the side of the cone. This is your C point, this is your F point, and this is your O. So here, denser medium, as usual, this is your denser. This is your mu2, and rarer medium, I'll take it as mu1. Okay, mu2 and mu1. So let's see. So what I'll do, I'll take an object. I'm just taking the object within the denser medium. So assuming I'm just taking an object. So this is your object. From the object, what I'll do, I'll pass a light ray. Light ray pass panittu. And it makes an angle alpha from your principal axis. From your principal axis, and this is your incident ray. And இதுக்கு வந்து ஒரு normal line இருக்கும். It travels from your center of curvature. So assume this is your normal line. This is your normal line, and it is perpendicular to the surface of the convex. So here it makes an angle. This angle is nothing but your angle of incidence. So I'll take this point as end point because this ray we call as not reference line. If light ray on the bend out, So bend ஆகுறது எப்படி இருக்குன்னா, so it will be away from the normal line. Remember denser medium இருக்கும்போது it will be towards the normal line. So when it is from denser towards the error, it will be away from the normal line. Like when it is away from the normal line, so here this is your image and it makes an angle beta. Okay. Now, so and இதோட refraction எப்படி இருக்குன்னா, this is your refraction R. Okay. So refraction இருக்கு, image இருக்கு, object இருக்கு, and center of curvature வந்து I'll take the angle as gamma. Distance பார்க்கும்போது from pole to the center of curvature, the distance is R. From object to the pole is your U. From the pole to image, the distance is V. Okay. Now, so what I'll do, I'll take a perpendicular point from the principle of curvature covering the structure, curve structure. I'm just taking a perpendicular point. So I'll take the point on the principal axis as M, a perpendicular to the principal axis. So let's see the triangles here. So same thing, same triangles. I'll take two triangles. One is your triangle NOC. Triangle NOC. So in this triangle NOC, the outer angle. Here, the outer angle is different. Earlier, the outer angle is your angle of incidence. Now, outer angle is your gamma. N point, O point, C. The outer angle is your gamma. So gamma is equal to I plus your, sorry, gamma is equal to, yes, I plus alpha. From this relation, I'm going to find I. I is equal to gamma minus alpha. This is your first relation. And let's see the angle, triangle NIC. So from this NIC, so the angle, outer angle is nothing but your refraction R. R is equal to your beta plus gamma. So R is equal to your beta plus gamma. This is your second. Now, friends, same thing, I'm going to find your angles. So alpha is equal to your opposite side, that is your NM divided by MO, and beta is equal to your NM divided by MI, and gamma is equal to NM divided by your MC. Okay, so let's see. So here we are going to see your Snell's law. Snell's law, here it is traveling from your denser towards the error. Our relations of this like change happen. So here in this case, so it will be mu1 divided by mu2. The ray will be passing from denser towards the error. That is a mu2 with respect to 1, which is equal to your sin I divided by your sin R. So what I'll do, I'm going to cross multiply. So sine functions now omit pandra because angles are so small. So mu1 into R is equal to mu2 into I. So I'm going to substitute I and R in this relation. So it is a mu1 into R. R is nothing but your beta plus gamma, which is equal to your mu2 into I is equal to gamma minus alpha. So here I'm going to substitute alpha, beta, gamma in this relation. So it is mu1 into beta, it is an M divided by Mi, plus gamma is nothing but your Nm divided by Mc is equal to mu2 into gamma is nothing but your Nm divided by Mc minus alpha is nothing but your Nm divided by Mo. So Nm will get cancelled in all the cases. Now we are going to see the sign conventions. In the sign conventions, towards your left side, எல்லாமே வந்து negative, towards your right side, எல்லாமே positive சொல்றோம். But இங்கே light ray is from your denser medium. Remember, from the denser medium. Denser medium சொல்லும்போது same thing, MO is your negative because it is opposite way. Left side there. And MI is your towards your right side, so it will be plus V. And the center of curvature on the towards your left side, MC is equal to plus R. I'm going to substitute the relation in the upper part. So it is a mu1 into 1 by Mi is nothing but UV plus it is a minus R. Sorry, it is your minus R because it is your left side. So it is Mi divided by minus R. So it's equal to mu2 into it is a 1 by minus R minus 1 by Mo. Mo is nothing but minus 6. So R terms one side and U terms one side. So the relation is mu1 by V, and here the minus of minus plus side. So when I shift it, it is minus mu2 by U is equal to the relation is mu1 minus mu2 divided by R. Okay, this is your relation. So in the relation, I can rewrite the relation into mu2 minus mu. Minus common or else you can keep it like this. So earlier relation the relation change. So இதில் வந்து நீங்க பாத்தீங்கன்னா mu2 is a denser. So denserல வந்து object இருக்கு, rarerல வந்து image இருக்கு. Remember this case. Let's take it down. This is the third application, third case. This is the third case. So the third case on the real image, but we are discussing about the denser towards the rarer. Okay.
I'm done.
Good. Right now, good. Let's see next one. So next one. Next one. The fourth case, convex of fourth case, we are going to discuss about the virtual image. So let's see. Fourth case, convex. So the light ray, as usual, the light ray passes, the object lies in your density. Light ray passes from density towards the radar. That means object lies in density. Okay. And the image form is your virtual image. Image form is your virtual image. Let's see. So same thing. So this is your principal axis. I'll just take the convex like this. And this is your P point, and this is your focus, and this is your center of curvature. So, denser medium. So I'll take this as denser medium. I'll take this mu2. It is your mu1. This is your denser, and this is your rarer medium. So light ray on the I'm just taking object. I'm just taking in your denser medium. Let's see that. So I'm just taking an object. So object எப்படி இருக்குன்னா இது virtual image இருக்கணும். So let's see that. So here I'll just take an object. So I'll allow the object passing through it. So what will happen? This is spherical surface. It is closer to your pores. Image it will try to refract. Let's see. So here this is your object ray, and either the angle on the I'll take as alpha. And in this case, a light ray on the bend with respect to your normal line. Let's see. This is your normal line. So normal line away from the normal line. So here, this is your normal line, and in the angle it is your angle of incidence. Light ray it will try to bend, and it will be away from the normal line. Like this. Bend, and it will be away from the normal line. Let's see that. So it will be away from the normal line. When it is away from the normal line, there are trace of points, it will be meeting within the denser medium. So this is your image trace points. Okay. So and either angle I'll take as beta. Remember, on the alpha is beta, and this is your gamma. Okay. And either angle of refraction this one. This is your R. And I'll take this point as N point, and this is perpendicular. I'll take M point. Perpendicular to your principal axis. So I'll take a point M. Okay. So let's see the distances. Object on the pole, the distance is here U. Image on the pole, the distance is V. Central point on the pole, the distance is here R. So angles here I, alpha, beta, gamma, and as well as here R. So here, let's see the triangles. As usual, two triangles are there. From the triangle NOC. From the triangle NOC. So here the outer angle is your alpha here. So for the triangle NOC, the outer angle is your alpha. So alpha is equal to I plus gamma. So from this relation, I is equal to alpha minus gamma. And from the triangle NIC is equal to the outer angle is your beta. In this case, so beta is equal to, remember, beta is equal to your R plus gamma. So from this relation, I need to find R is equal to your beta minus gamma. So now I'm going to find alpha beta gamma. So alpha is equal to your NM divided by MO. Beta is equal to M divided by MI. Gamma is equal to NM divided by your MC. Now I'm going to take the Snell's law from denser towards the radar. So it is mu1 divided by mu2 is equal to, this is sine I divided by sine R, which is equal to, it is a 2 u1. Remember. Now the angle functions are omit because the sine functions omit because angles are so small. So I'll multiply it. So mu2 into R is equal to mu1 into I. So I'm going to substitute the relation here. So mu1 into R relation another, R is equal to beta minus gamma. R is equal to your beta minus gamma. So which is equal to mu2 into, so this is your mu2 into I. Mu2 into I is equal to your alpha minus gamma. I'm going to substitute this alpha beta gamma. So it is mu1 into what is beta? It is Nm divided by Mi minus gamma is equal to your Nm divided by Mc is equal to your mu2 into alpha is equal to nm divided by mu minus gamma is equal to nm divided by your mc. Nm will get cancelled in all the directions. So it is a mu1 into mi. What is mi? Yeah, I'll take the sign convention. So from the sign conventions, so it is a mi is equal to. So all are towards your left side. எல்லாமே வந்து towards your left side இருக்கு. I take it is your minus v. Mo is equal to minus u and mc is equal to minus r. I'm going to substitute that relation. So it is a mu1 into mi is nothing but your minus 1 by v, or I'll take it as a 1 by minus v minus 1 by minus r is equal to mu2 into 1 by minus u minus 1 by minus r. R will be plus here. So here also plus. So the relation will be u1 by minus v. Okay. So mu1 by minus v. So mu2, I'll shift it. R values at the work side. So it is a plus mu2 by u is equal to, it is a mu2 minus a mu1 by r. So நான் என்ன பண்றேன், minus ஓட multiply பண்ணும்போது the relation will be like this. u1 by v minus mu2 by u is equal to u1 minus mu2 by r. Remember earlier நம்ம டிஸ்கஸ் பண்ண ரிலேஷன், இந்த ரிலேஷன் ரெண்டும் சேமா இருக்கும். எதுக்குன்னா இங்க வந்து டென்சர் டு ரேரர் பார்க்கும்போது ரியலா இருந்தாலும் வர்ச்சுவலா இருந்தாலும் சேம் ரிலேஷன். So these are the four cases under convex. Note பண்ணிக்கோங்க.
Done.
Okay, right. So now we'll discuss about the concave. The same relations, concave. I'll explain the image and I'll share you the documents. Okay, ஏன்னா வந்து ரொம்ப stretch பண்ண வேண்டாம். Same concept தான். So we'll see the image, how the image will be formed. So next one is a refraction at concave spherical surface. Refraction at concave spherical surface. So there are two relations, two cases. First case is your object lies in the rarer medium. Object lies in rarer medium. Okay. Second case, object lies in denser. Object lies in denser medium. So let's see both the cases here. So now on the picture experiment, I'll give the final relation. Whatever the relations we have seen for convex, same relations there. So first case, here the object lies in your rarer medium. So I'm just discussing about your concave. So what I'll do, I'll take a principal axis as usual. So there is a principal axis, and for this there is a concave surface. This is your concave spherical surface. So for this concave spherical surface, there is a denser medium. This is a denser medium. And in the denser medium, in the concave, the center of curvature on the front forward. So this is a center of curvature, C. And this is your pole. So it is a denser medium, I'll take as D. Either a refractive index on the, I'll take as mu 2. A rarer medium R, either a refractive index on the mu. Okay. Let's see. So here, what I'll do, I'll take an object. Light ray on the pass on it, okay? So this is your object. That's different for us. Let's see. So object or light ray on the pass on it, okay? When the light ray passes, with respect to your normal line, reference line, and then will try to refract. So there is a reference line. So it travels from the center of curvature. So it's on the surface to perpendicular. So this is your center of curvature. So in the light ray, it will try to bend. Bend towards the normal line. Bend towards the normal. That's it. So it will be bending towards the normal line, like this. So either towards the normal line, let's see the angles. So here this is your object, and either angle on the alpha, and this is your point. I'll take this point as n. Either normal line, and either refractions on the light directions, and it is your refraction r. Either tracer points, it will be formed here. These are your tracer points. Okay. So and this is your beta. This is your image formation, and this is your gamma. So let's see the distances. From object to the pole, the distance I'll take it as u. Image to the pole, I'll take the distance as your v. Your center of curvature to the pole, I'll take the distance as r. Okay, so either angle of incidence, angle of incidence. This is your angle of incidence. Okay, and refraction alpha, beta, gamma, and what I'll do, I'll take a perpendicular, and that is your NM. So perpendicular to your principal axis. I'll take this one as okay. So this is your rarer towards the denser. NO triangle NOC, triangle NOC, triangle NSC. I'm going to find I and as well as R. After that, alpha, beta, find out pannu. After that, we are going to use the Snell's law. So then after that, we'll see the relation. I'll give the final relation. Same thing. It is similar to your convex nulla. I'll give the final relation here. So in this case, the final relation here, rarer to denser and ஒரே ஒரு relation, whether it is concave or convex. The relation is this. So it is a mu 2 by v minus mu 1 by u is equal to this is mu 2 minus mu 1 divided by r. Remember it. So when the light ray passes from rarer towards the denser, whether it is convex or concave, real or virtual, the relation is same. Please take it.
Done.
Yeah. One second. Right. So one last thing. So after that we will stop. Okay. So the last one is your concave. Same thing concave, but the image object is formed in your uh, denser medium. Let's see. So here it is your concave, but the object is lies in your denser medium. So let's see the picture. So this is your principal axis, and I'm just taking a concave surface. This is your concave surface, and this is your denser medium. This is your denser medium, and let's see. So denser medium சொல்லும்போது either denser refracting index mu2 and there are rarer refracting index mu1. Okay, it is the center of curvature on the C. And take the C point. Let's see. This is your core. Now what I'll do, I'll allow a light ray from the denser towards the rarer. Assuming this is your object and your light ray pass ஆயிட்டு. So இதுக்கு ஒரு reference line இருக்கணும். So that reference line is something but your normal line. But here this is your object. It makes an angle alpha. So இதோட reference line வந்து this is center. This is the center of curvature. So this is the reference line. So இப்போ என்ன இருக்கு, the light ray should bend. Bending எப்படி இருக்குன்னா away from the normal line. When it is away from the normal line, the light ray will be like this. It will be away from the normal line. The light ray will be like this. So when you trace out, so what will happen? It will be forming within the denser medium. So this is your virtual image. So here, this is your image. It will be forming within the denser medium, and it makes an angle beta. And here, this is your angle of incidence. This is your angle of incidence. So this is your angle of incidence and angle of refraction. This is your angle of refraction. Alpha, beta, and this is your gamma. Distance பார்க்கும்போது from the pole to the center of curvature is r, from the image to the center of, that is your pole. Image to the pole, this is your p. Object to the pole, this is your u. Okay. Sign conventions lo பார்க்கும்போது towards your left, sign conventions lo வந்து, so it is u is negative, v is negative, r is positive. So from the sign conventions. And either are relations work on the same thing, and I'll take this one as endpoint, and either a perpendicular point, I'll take this m. And nm comment on the point and the common to the all the angles. So in this case, so light ray on the passing from the denser towards the rarer. So either a relation, funnel relation. So I'll give the funnel relation. Same thing as your convex itself. Funnel relation is mu1 by v minus mu2 by u is equal to mu1 minus mu2 by r. Remember when the light ray passes from your denser towards the rarer. So this is your relation. Remember, இதுல வந்து எல்லாமே virtual images தான், எதுவுமே real images. Concave all are your virtual images. Just take it. So just go through it. If you have any doubts, you can ask me in next classes. So the relations எல்லாம் further பார்த்துக்கலாம். These are much important for your problems.
Saturn.
Yeah. Okay. Right. So just go through these relations. Okay. In next class, we'll see the lens Matrix formula and as well as your thin lens formula. So I'll stop the recording. Okay. So what are the doubts are there? You can ask me in your next class. Save it.